Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths B. We have started a discussion with all chapters of 1B, that is starting from the geometrical chapters, that is locus, transformation, straight lines, pair of straight lines, right? And we also learned few calculus chapters, that is limits, continuity, differentiation, right? Today we are going to start a new chapter, an important chapter, that is applications of derivatives. What are these? Tell me, till now we have learned different chapters such as straight lines, pair of straight lines. Hope you all know what are these applications. Yes, because as we are going to construct something, as we are going to define something, we can define it in the coordinates of a xyz. That is, we are using a rectangular coordinates in that. So we can easily identify. When it comes to other chapters such as limits, differentiation is the direct application of limit, isn't it? Because our first principle itself is based on limits. Okay, when it comes to applications of derivatives, there are numerous applications, such as, if you know, let me tell you a basic example, that is, what is the volume of a sphere? Just tell me. The volume of a sphere is 4 by 3 pi r cube. Okay, now let us differentiate this with respect to this variable. What is it? That is r. Okay, if I differentiate it, I will get 4 by 3 pi as constant. R cube ka differentiation is 3r square, isn't it? If I cancel it, what do I get? 4 pi r square. What is it? Any idea? That is nothing but my surface area of a sphere. Yes or no? Yes, right? Once again, let me tell, if this is the volume of a sphere, then if I differentiate it, I will get the surface area. And not only that, whatever the parameter you take, or else let us take one more parameter, area of a circle, pi r square. Okay, differentiate it, what it will become? It will be pi into 2r. R square ka differentiation is 2r. Therefore, this is 2 pi r. What is this? Circumference of a circle. Yes or no? Is it not easy to solve? These are the main direct applications which you can easily identify. Clear? And not only this, there are few things such as tangents and normals. How do we find the slope of a tangent? Just tell me. We used to do different formulas. Yes or no? Here, in order to find the tangent slope of any curve, okay, how do we find is just to differentiate that curve. Okay, if I say y is x and y, it is some equation, then just differentiate it at a particular point, that will be our slope, isn't it? Based on this concept, we will solve few questions. Okay, and not only this, there are many important key concepts to be learned in this chapter. Okay, shall we start? Fine. See here, the first topic which we are going to learn in applications of derivatives is errors and approximations. Okay, error approximation. Where did you hear this word? This is not some kind of physics. Even however physics, whatever the measurements we do, that is directly applicable in this chapter. Yes or no? Which means this error and approximation. What is that error and how do we approximate it? How do we define it? Okay, that's what we are going to discuss in this chapter. Okay, see here, if I have a parameter y is equal to f of x. Okay, let me tell this y will have two different values of f of x. That is, for example, this is some curve like this with respect to t or some x. Okay, this curve will have different values at different values of x. Okay, then what is the difference between those two? Just tell me. You would have learnt in your physics initial chapters, that is measurements. That is, the parameter of y at this x2 minus the parameter of y at x1. Okay, that is the value. This can be simply called as delta x. we always used to write as x2 minus x1, isn't it? What is that delta means? Delta itself, it means that separated, that is change in x. Okay, that change is simply given in discrete form. Okay, it is changing from x2 to x1. Okay, what if it is changing without time? Yes or no? This is changing at different instances. What if the variable changes independent of time? That is, it can change to any value. That is nothing but your derivative. That is, it can be represented as dx. Okay, that is called as change. Okay, simply to tell, this is a digital change, this is non-digital, or simply an analog change. Yes or no? This means it is changing continuously. Clear? That's what we always define a velocity as change in displacement, isn't it? Yes or no? The rate of change of the change of displacement with respect to time. Why do we write ds by dt? Because it is specifically changing with respect to time, and not only that, it is changing continuously. What if we write it as del s by del t? It clearly tells that this is the change in displacement by change in time. That is, it may be between 2 instances or more instances, but which is countable. Okay, it may not change continuously, it is changing discretely. Hope you understood. Fine. At least you may, even if you have any doubt, by looking at these kind of formulae, we can actually identify it. Okay, see here. What are the different formulas which we are going to use in this chapter is dy. This is nothing but the differentiation of y, or simply the y ka differentiation, the change in y, where if y is some function of x, okay, which means x is changing here. If you observe, here it is change in x, then the y will change in this form, that is dy is equal to f dash x into delta x. Okay, fine. Next, similarly, what is this delta y? That can be written as the x plus delta x minus f of x. How do we define this? Is, for example, this is, let me draw it again. If this is some function, okay, at this x1 and this is x2, okay, what is the change in between these? Let us say delta x, that is nothing but x2 minus x1. Okay, he is telling that f of x plus delta x, if this is x, this will be x plus delta x, isn't it? That will be whatever the value which I get here, that will be f of x plus delta x minus f of x. Okay, that is the change in y. Is it not a digital change? Yes or no? This is this formula. Similarly, from this we can combine these two, and I can write it as f of x plus delta x is equal to f of x plus del y. Del y is f dash x into del x. Okay, is it clear? Fine. These are all the basic things. Based on this, we can even calculate del y by y, which is a relative error. If I want to do the percentage also, I can do, that is percentage error. Clear? Hope you got a basic idea. Shall we start doing the problems of errors and approximations? Let's do. Look at these questions here. He is asking to find delta y and dy for the following. What is this y? Y is some function of x. Okay, that is, just tell me what is the formula of delta y? Delta y is f of x plus delta x minus f of x. Is it? Now, what is this x? 10. What is delta x? 0.01. Just substitute in this. That will be delta y is equal to f of 10.01 minus f of 10. Okay. The only thing, substitute it, simplify. Okay. See here. 10.01 square plus 3 into 10.01 plus 6 minus 10 square minus 30 minus 6 will get cancelled. Okay, just simplify this and solve. What's the square of 10.01 square? Tell me, what will be its square? Somewhat more than 100, right? By simplifying everything, you will get it as 0.2301. We can simplify it. Similarly, what is the formula of dy? dy ka formula is f dash x into delta x. What is f dash x? Tell me. 2x plus 3, isn't it? Into delta x. What is x? 10. That is 20 plus 3 into 0.01. That is nothing but 23 into 0.01. That is 0.23. Okay. Mostly you will have same answer. Okay. Shall we move on to the next problem? See here. Here also the same formula we have to use. What is delta y formula? F of x plus delta x minus f of x. Okay. What is x here? 8. There 0.2. That will be 8.02 minus f of 8. Okay. Just let us substitute the value of this instead of this. Okay. See here. 1 by 8.02 plus 2 minus 1 by 8 plus 2. That is 1 by 8 plus 2 is 10.02 minus 1 by 10. Okay. Just try to simplify it. How do we simplify? You can take LCM also. It's okay. 10 into 10.02. 10 minus 10.02. Okay. That is, if you will get minus 0.02 in the numerator, and the denominator you will get 10 into 10.02. Okay. If you divide everything, you will get 0.000196 something. Okay. Similarly, let us find the value of dy. dy is equal to f dash x into delta x. That is nothing but, what is the differentiation of this? 1 by x ka differentiation is minus 1 by x square. That is minus 1 by x plus 2 whole square into delta x. What is x? 8. 8 plus 2, that is 10 square, that is minus 1 by 100 into, what is x? 0.02. Okay. If I divide by this one, you will get it as 0.0002. Almost similar value. Okay. These are the basic problems of errors. Shall we move on to the next problem? Let's do. Look at this question here. He is telling to find the value of square root of 82. Is 82 a perfect square? Then how do we calculate the square of 82? That is, we know the nearly value, that is, we know the square root of 81, that is 9. So, how do we approximate it? That is, this is very important, this kind of questions. We will assume f of x as root x. Okay, where x is 81 and the change in x is 1. Okay, let it be 1. Okay, is it clear? So, we have to find the value of 82, that is f of x plus delta x is equal to f of 81 plus 1, that is nothing but under root 81 plus 1. Is it? Yes or no? That is what we have to find. What is x here? 81. What is delta x? 1. Okay. What is the formula of x plus delta x? That is nothing but, tell me, f dash x into delta x plus f of x. Is it right? Now, thus we have to find the values of all this and substitute in it. Okay. What is f dash of x? That is f of x is root x. F dash of x is 1 by 2 root x into delta x plus f of x. What is f of x again? Let me write it as just root x. Okay. Now just substitute the values of x and all those. 1 by 2 root x, that is root 81 is 9, delta x is 1 plus 9, that is 1 by 18 plus 9. Okay. What is 1 by 18? Yes, that will be 9.055 and so on. Is it clear? Is it not easy to find? It is almost near to 1 but not 9. Clear? Fine. Look at the next question. He is telling that if increase in side of a square is 4%, then he is asking us to find the approximate percentage of increase in the area of square. Okay, there is a square. Let us say the side is x. Okay, he is telling that the increase in this size, percentage increase, that is delta x by x into 100 is 4. Is it? Then how do we approximate the area of square? What is the area of a square? Side into side. Fine, we have to find del a by a into 100, that is del a by a. Okay, let me differentiate it. Let us not do anything. Del a is 2x into del x. Yes or no? Fine. Or even if you don't understand, let me tell, if it is just area x square, if you want to differentiate it, I used to write dA by dx is equal to 2x. Okay, just I will send the dx this side. Can we? Fine. I want del a by a into 100. So let me divide a on both sides. That is del a by a is equal to 2x into del x by a. Okay. What is a here? 2x del x. A is x square. This is del a by a. X will get cancelled. Okay. I will be left with del a by a equal to delta x by x. Let me multiply 100 also into 100 is equal to 2 into del x by x into 100. Is it fine? What is this? Del x by x into 100, that is nothing but 4. Therefore, 2 into 4, that is nothing but 8. This is del a by a into 100. Therefore, the area increases by 8%. Clear? Did you understand? Fine. We have covered almost all varieties of problems in this errors and approximation. What did we learn? We started with the basics of relative error, absolute error, and dy del y, f of x plus delta x. These are all formulas we have learned today, and we have discussed few basic problems of them. Clear? Fine. This is for today. Let us meet in the next session with the more problems of applications of derivatives. Thank you.